gravitation, the force of attraction is F is equal to G into product of the masses. What will be the masses? In first case, the masses are m1 and m2. So G into m1 into m2 divided by what is the distance there? The first case, the distance is small letter r. Therefore, we write F is equal to G m1 m2 by r square. Here, what is the attraction between force of attraction between earth and the object? That is G. What is the mass of the earth? Capital letter M. What is the mass of the object? Small letter m. By what is the distance between earth and the object? That is capital letter r square. This is taken as equation number 1. Next, there is also another force acting on the particle or the body or the object. That force is called weight. What is mean by weight? The force exerted by the earth on an object is called weight. The force exerted by the earth on an object is called weight. What is the equation for weight? Equation for weight is W is equal to mass of the particle into acceleration due to gravity at that place. That is mg. Mg is the equation for weight. So we can say that weight is simply force. Why? Because the force exerted by earth on an object is called weight. So weight is simply force. So the force acting on the object by the earth is called weight. So next one, we want to find out the force acting on the object. Force acting on the object simply is called weight. Force acting on the object is called weight. Who exerted that force? That you know. Who exerted that force? That force is exerted by earth. So the force exerted by earth on that object is called weight. So it can be written as F is equal to, in place of W, I write F. Why? Because weight is also force. F is equal to, what is the force acting on the object? Mass of the object, small letter m into acceleration due to gravity is small letter g. This is mg. Equation number 2. We have to compare these two equations. Comparing 1 and 2, because in 1 and 2 the left hand side is force, so the right hand side is also same. So if the left hand side is same, the right hand side must be same. So we have to equate the right hand side of 1 and 2. Comparing 1 and 2, the left hand side is F itself. Comparing the right hand side, we got G capital letter M small letter m by radius square capital letter R square is equal to small letter mg. What are quantities? So what quantities cancels each other? So small letter m cancels each other. These are the quantities cancels each other, and finally the equation for G is equal to G equals small letter g equal capital letter G capital letter M by capital letter R square. So this is the equation for G, small letter g. Acceleration due to gravity, small letter g is equal to capital letter G m by R square. What is capital letter G? Universal gravitational constant. What is capital letter M? Mass of the earth. What is capital letter R? Radius of the earth. So from the equation, it is clear that there is no influence of mass of the body and no influence of radius of the body. Okay. So which simply means that acceleration due to gravity is independent of mass of the body and the radius of the body. It only depends upon the mass of earth and the radius of earth. So universal, according to universal law of gravitation, we got the force between earth and that object is gmm by r square, and the weight acting on the body is also a force exerted by the earth, that is mg. By comparing these two equations, we got the value for acceleration due to gravity g is equal to capital letter gm by r square. From this equation, it is clear that acceleration due to gravity is independent of mass of the body small letter m and the radius of the body small letter r. It only depends upon the mass of the earth, capital letter M, and radius of the earth, capital letter R. Capital letter G is a constant and is called a universal gravitational constant. So these are the things we studied in the second section: the importance of universal law of gravitation, what is meant by free fall, how it is related to acceleration due to gravity, what is the expression for acceleration due to gravity, and what is meant by projectile. So next 4 topics we want to discuss in the next section. Now we are going to discuss the third section. The third section consists of the topic motion under gravity, mass and weight, and their units. So how to discuss about motion under gravity? That's a great problem, because most of the problems in the chapter coming under this section, motion under gravity, because it's a confusing section. Okay, so here we consider a body. Okay, it is moving upward and downward. By that condition, I modify this this section. I modify this section, motion under gravity, into split into different simple sections. Okay. First of all, to study motion under gravity, we want to know whether there will be 3 equations of motions are there that you studied in the chapter motion. What all the equations are there? The equations of motions are: number one equation of motion is V is equal to U plus AT. The second one is 2, S is equal to UT plus half AT square. The third one is V square equal U square plus 2AS. So these are the 3 equations of motion. V is equal to U plus AT, velocity time relation, S is equal to UT plus half AT square, displacement time relation, and the third one is velocity distance relation, velocity position relation, like that. Okay, so what is mean by free fall? As you all know that if a body is dropped from a particular height and if that body is moving under the influence of acceleration due to gravity, then that body is said to be in free fall. So in the case of free fall, there is an acceleration experienced on that body, and that acceleration is called acceleration due to gravity. And in the previous section, we discussed about what is mean by acceleration due to gravity. What is acceleration due to gravity? The acceleration experienced on a freely falling body due to the gravitational pull of Earth. So here, in the case of acceleration, all the 3 equations, there will be acceleration. V is equal to U plus AT. A is acceleration, here A is acceleration, here A is acceleration. In place of acceleration, we have to put acceleration due to gravity. Then this equation is valid in the case motion under gravity. Here we consider a path. This is a path. So this is P and this is Q. If a particle is moving from Q to P, that is means this is in the upward direction. This is in the upward direction, Q to P, and P to Q is downward. Okay. If a particle is moving in the upward direction, that is opposite to the direction of gravity, which simply means that Earth attract all the object towards the Earth. That means that Earth attract all the object towards the center of the Earth, means that all the object is towards the center of the Earth, that is downwards. The acceleration due to gravity influence is downwards. So if a body is projected upwards, is there any influence of acceleration due to gravity? Yes, there is an influence of acceleration due to gravity. But the thing is that at that time, if a body is projected upwards, in place of G, we take minus G, because it is opposite to the direction of the influence, opposite to the direction of the influence of gravity, opposite to the direction of the influence of gravity. If a body is coming from upward to downward,